Let's talk about how this freezer broke down after a power outage, or maybe after being switched back on. We will never know for sure. Apologize for showing it already disassembled, but recording a video about the repair wasn't my first thought. I was more focused on identifying the issue and attempting a fix. We will circle back to this, but first let me explain how it failed. So the indicator won't light up, the compressor won't start, and it emits a beeping sound at regular intervals. If you search online or check the manufacturer's FAQs, you will find the basic troubleshooting steps like waiting 30 minutes and restarting. However, I immediately knew this wasn't just a glitch but something has failed. But for simpler case, those standard solutions might work for you. So what my theory and why I'm trying to repair it instead of buying a new one. This freezer is 16 years old. Can you imagine? It has served well. I've been monitoring its temperature profile. Here is the temperature using iSocket. Here is the iSocket. That's a topic for another video, and I will link it in the description. The point is, I know that the compressor was working perfectly. And let's take a look at the profile, actually. Let's take a look just briefly at the temperature profile. I monitor it. See, the compressor operation is flawless. And those spikes are from opening the door. If this graph doesn't make sense to you, I have in-depth video about this feature. So, and I promise to be briefly, so let's get back to our freezer. Well, maybe I lied a little bit about the perfect diagram, because I have new freezers and there are actually really perfect temperature profiles. Again, you can watch my video about this, dedicated video. So I don't want to replace this made in Sweden freezer to the modern, made in China junk. I want to keep using this. Plus, it's environmentally disaster to throw all this away, this and these things, if only a small component has failed. My guess is that the control board with the power supply has malfunctioned. I will show you this now. Here's the board I removed. At first glance, nothing looks burnt or broken. I researched under the microscope also. Plus, the buzzer emits a periodic sound, meaning to me the power supply AC-DC conversion are likely working. I suspect probably the firmware of this processor might have failed. On another hand, if the buzzer is beeping periodically, what's controlling that timing if not the processor, not the MCU? Could it be done using discrete components? I'm not sure. I couldn't find a schematic to confirm this. So next came the saga of searching for this board. There are so many markings to go through here, a lot of different, and also here. And I had to try matching each one to find anything remotely similar. Guys, I'm sharing this because you might face the same search process let me show you what I discovered soon. It was impossible to find the exact match. From what I understood, actually, this Procond Electronics is the Italian company that made this board has shut down, so they don't operate anymore, in my understanding. Let me now show what I found. For example, this one looks identical, absolutely identical, but numbers are different. This one again looks the same, but again some other marking. And this one, and again something else. So I reached out to Electrolux, and they provided a link to this replacement part with the clear name Voima Yksikkö for this money, with that part number that you don't see anywhere on the plate. And they assured me that it's exactly what I need. Here is no picture, but let's talk about it and meditate a little bit. I will explain what is going to that English, sorry, what I'm going to receive. So it is coming in this way. I just dropped the cover to simulate, to show you. So the full part, including this LED, this plastic part, and the board inside, and I meditated over this. Probably inside there will be a different board, and if it produced to their new subcontractor, for example, they probably even can have a new processor firmware. And guys, but these connections actually, as I don't know, but I think they are unified in their freezers. Connection to the temperature sensors, their own, not iSocket temperature sensor, but their own. To the compressor, they are unified. And then you can, if you are going to replace the controlling board, and for example, you cannot produce just one part, this part anymore. You can produce the full new controlling board with new LED, with new buttons. By the way, it looks like they will be gray, and the new program inside the MCU. So I really hope and expect that it will work, and we will know soon or later. I'm eagerly waiting for the replacement, and if it works, I'll start reassembling the freezer and show you the process. Fortunately, I can't show you the disassembly anymore. As I mentioned, I didn't plan to document it. However, the reassembly should help you to get an idea how to make disassembly, right? So I am recording this as a log for myself. But anyway, if you find it helpful, don't forget to like, subscribe, and leave a comment. And if the new board doesn't work, well, let's stay optimistic. And here we've got this part. So these buttons are gray instead of original white. First, let's try it here and then make any other decisions. The moment of truth is approaching. The last connector. And now let's try. Whoa! Amazing, it works! The lamp lit, this is beeping, and the compressor operates. By the way, let's shut down it in the right way. Yeah, I forgot where the power button is. So it's here, and of course we will open it and see and compare with what we had before. And by the way, it's a little bit about disassembly order. I realized later that first you need to undo this one, these two, and then you can split these two halves. I will do this way. I'm not going to show it. So it's a simple task. You just put a screwdriver here, and then you can also remove the buttons. By the way, you can replace them. So I need to decide with my boss which color is preferable. And then you open here again with the screwdriver, and probably here on the sides too. Yes, guys, as I expected, different part numbers, right? So look at here, the old one and the new one. So different names, the same looking board, a little bit different. Like transformer here has the knots without tape, let's say, a little bit different capacitor. Quite the same resistors, I guess, varistors. Yeah, so let me put it this way, the old one, slowly, you can pause it. I also make good resolution photos for myself. So, but guys, it's still, yeah, here is very well seen this ST microprocessor. It's still Procond, so, and the manufacturer date, I think it's probably, we will meditate about it later. I don't want to open and see the opposite side, but guys, I think I guessed right that probably it's MCU firmware failure here. Yeah, and probably my guess about that this is the new subcontracting is also the right one. I'm not actually sure, but that's what we have. So 14, 24. I think it's 24, the old one, 24 and week of the E8. And guys, I think, and here I think it's the 14 week of 14 year. But this is for this board. What about that one? Here is, so I think it's week, yeah. So on the old one, I think it's the week 34, the E is 8. Yeah, and here is week 34, year 14. So it is from the 2014. So it's quite oldie. It's still old, yeah. So it is probably from Procond. That was not yet closed, from old stock. So yeah, should I buy another one in case if it will never be produced again? I don't know. So guys, I have it for you, and I hope I got the like and subscriptions. Let's go to the assembly process now, and watching the assembly process you can also understand how to disassemble this. Dear cat, don't hope you will get this place, it will be occupied soon again. So guys, this part goes to here on the two screws there. So when you when you opened this part from that part, it's the easy process. You just unscrew two screws and then you remove all cables. Here is some kind of cable management. It's easy. So I will put it back, and then we discuss how we open that part. And guys, you don't need to open anything here. I undo two screws because I was thinking that's probably I need to access it there. No. Do you confirm? So, and you don't need to open this wall. I did it again, because I wanted to check if there is some entrance to the power supply from there. Finally, I decided to install iSocket temperature sensor. Here is another video I think I mentioned. So you don't need to walk here, but you need to open the door. It was a little bit challenge. There, it's just sit there. You don't unscrew anything. You need to remove a hinge from here. That is on the 2 screws or bolts. I don't remember. We will know it soon. So it can be installed either side. It was a little bit challenge to remove this door. Probably I did it not exactly right, but okay, we'll get back to this. So that part first. Here's the kind of inconvenience with this top side, because it has cables here, so I don't want to rotate it. I don't want to damage them. Probably it's okay, but I did all my job in this position. So, and here we have the lamp, halogen lamp. It goes to here. We can see the radiator for this lamp here. Yeah. So I think I'm not sure, but I think you don't need to open everything in case if you need to change the lamp. So probably you can install the lamp later, and you probably can open this glass. I don't know, but I will try to install it now. I just give you the idea that the lamp is separately from here. It has the connector here from this transformer. Some wires from this transformer also go to here. I don't know their purpose, because I measured here 230 volts. And now about this part, you can see it has fixation here and here, so it goes here and here. When you open it, you need to use a kind of flat screwdriver, some help, and undo it here and there. It was a little bit challenging. I was afraid to break the plastic, which is 16 years old. So, but you've got the idea at least. So I put this part now back there with the lamp, and let's see what next. So we have this part assembled, and it looks this way. So it's like a separate top part, and there are 3 wires that you have seen already. So I didn't need to reverse it. So, and now I should align it with this part, and we will have 2 screws here. One is here, another one there, and we have some screws. I don't remember right now. So we have 3 holes here. Probably again 1 and 1 for this top part, and 2 for hinges. Yeah, I'm pretty sure that's it. I will do it and finally show you the result, and I think it will be enough for you to understand how to open it. You just need to remember that you just remove the door, unscrew this part. It's covered on one side, it's covered with the plastic, and then you just undo this part, and the rest is very simple. So we have 6 bolts here, and we have 2 screws, hexagonal screws. One is here and one is there. So it holds this part here. And 3 bolts on one side and 3 on another. Actually, 1 here and another one there. They hold this top part. So I hope I explained clearly, more or less. And these 2 are for the hinges. And actually, on the one side they will hold hinge, but on another side they just remain on their place, a kind of reserved bolts. They don't hold anything. And we have also this decoration plug here that you need to open with a flat screwdriver. And we have this here that you don't actually need to remove. This is on the side where you don't have hinges. So basically when you, and I actually also realized why it was inconvenient to remove the door, because you can remove this switch first. It's easy to do. Push here and remove it, and then you have better access to the bolt which sits here. So basically your process is to open this plastic part with the screwdriver, open bolts there, open bolts here and remove the door, bolts there, and here you are, you have access to this part, and the rest you have seen already. About screws and bolts, a little bit mixed up, but I will show you now. So actually this screw is here. I realized it after the bolt didn't go through. So the screw here, bolts here, the bolt here, and on the opposite side similar way. But it's not a problem, because when you open it you will see what kind of bolts you have and memorize for yourself. I haven't done it, and you see the result. Anyway, not a problem. This I have been talking about. In order to access this screw in a better way, you have to remove this switch. Unnecessary part. Let's check once again that it wasn't broken during the assembly. Now I will show you briefly how to install this wall. Again, it's not related to this problem, but there are some tricks. In some case maybe you need it, especially if you want to do the same like me did with the iSocket temperature sensor. So I will try to provide it through this part, and then we will do a kind of conclusion about how to avoid. Is it possible to avoid this problem in the future? In reality, I got a bit confused while recording material for two videos simultaneously, and the installation of this back panel so in another video where I talk about the temperature sensor installed there. You can see the temperature sensor there. I install it in this freezer through the back wall. I will add a link if the video is already published. So iSocket is here, the sensor is there now through the back wall. So it's here on its place, and look how nice it is now. No any cables through the door rubber ceiling. So the temperature sensor and the iSocket are there. By the way, it also monitors power outages, but let's talk about this later when we speak about how to avoid this in the future. So the temperature sensor is now there, so nothing here. It will never fall out, and it's here. So now I have a different option where to locate it, and I actually don't know where. So the temperature profile definitely will be different, because previously my sensor was through the door ceiling somewhere here. Now it will be there. If I allow this like to be free or loose, then it goes under the back part of this drawer. So can you see it there? Yeah. something like that. I'm not sure if this is good or not, but it doesn't matter. I will monitor the temperature profile and decide later. I also can place it here. For sure, I can also connect it with the net tire, like this way, yeah, here, or anywhere. I just probably don't want to tie it right now. In case if I need to remove drawers, I need to cut this tie. Well, it's not a problem. The idea, you got the idea. The sensor is somewhere there now, and the main point that no leak of cold when I provided the sensor this way. So I'm so excited about this failure, that I could provide the better temperature monitoring solution now for this freezer. Yes, my dear, I warned you. By the way, boss approved these white buttons as well as gray one, actually. What do you think about this new sound, like the freon is boiling? I never heard it before. Let's check the app to see the temperature reading from this sensor, actually -16.6, and my notifications are set to -13, and again in the log we can see when I had notifications, so it's quite often that it reaches -12.5 with that new location for the sensor. I receive email notifications, but also text, WhatsApp, call, possible, and some integration with webhooks. So, and we can also see, about this -12 notifications. We can also see the graph. I'm not sure if I cover it somewhere in this video, but I have a huge video about this iSocket feature, historical temperature data. So, and we can find a lot of interesting profile. I'm really keen to research this. So here we have this freezer, and we have that it is balancing between -15, -20 with some spikes here. Yeah, so peaks. Well, when the door is open, or probably something in the freezer's compressor. Otherwise, we have a nice graph like this when it starts, when it stops. So, and you can see -12 is somewhere there, and sometimes it is heated over this value, and that's why I have a notification. So I either need to figure out a new location for the sensor, or actually probably set a different limit for alerts, or at some point probably change the freezer. Yeah, 16 years, it's quite okay if sometimes it doesn't have that nice constant graph. Well, maybe you give me some advices about this coolant sound, like boiling coolant. Yeah, but let's discuss how to avoid such a problem happening again. So first, this issue occurred due to a high load on the circuit where it was connected here. So, and the fridge here, and I have also a washing machine, a dishwasher, and a kettle on the same electrical circuit. And if you accidentally forget about this and turn on the kettle while the washing machine or dishwasher is running, it trips the breaker. iSocket will notify me. But okay, so whether the control board failed during the power outage or when power was restored, there is no way to know for sure. But it's clear that reducing the number of sudden power outages is crucial. So, if possible, connecting this freezer into some other circuit would be the better solution, but I unfortunately don't have that option. It's the same circuit everywhere here. How about an uninterruptible power supply? Well, it's a good idea, but the UPS itself is a point of failure. For example, here I have this UPS, and when its battery fails, it stops providing power and disconnects the load. What about a voltage stabilizer? Well, I'm not sure if it would help or what exactly caused the board failure, especially if it was due to firmware corruption. So, if it was an electrical surge, maybe a stabilizer could help, but I don't know. Again, it would add another point of failure anyway. This iSocket plug-it in next to the freezer, yeah, as well as another one there next to the fridge, will notify me if the power goes out. So at least I'll know about it, but it's not about this one. So, by the way, you see, I don't plug the freezer itself into the iSocket because, well, it would be nice because I can measure the energy consumption of this freezer, but I avoid doing this because it would again add another potential point of failure. Here is how it looks in the app, by the way. So freezer circuit power is okay, and in the log I can see when I had power failure or power restore events. Please load. It's not the app but my Wi-Fi logs. So, and here I see events, and I subscribe to email notifications, but it's also possible to receive text, WhatsApp, call, and different kind of integrations. And I told that I don't use what happened here, so my Wi-Fi logs, that I don't use energy monitoring for this freezer because it creates extra point of failure, but I will show you otherwise how I could monitor like energy consumption. For example, actually in my garage, at least cooler fridge, I connected into iSocket, and also here was somewhere garage freezer. But okay, let it be. And also in the energy meter I could see consumption over time, but I should, yeah, garage, temporary heating, sorry, freezer garage, yeah. So I can see how much it consumes over the time. I could do this with my freezer here, but I explained to you that this will create another potential point of failure. So in general, reducing the number of sudden power outages due to overloading is the only thing you can realistically control. Well, I can in my case. And if the power goes out for other reasons, well, that's just luck. What will happen with the power board? I hope you found this material helpful. When I was looking for information on this topic, I couldn't find anything at all, so I hope you will appreciate it. Give it a like and most importantly subscribe. It helps a small channel grow.